Hi, Frank. It's great to see you and talk to you about nerves. Can you introduce yourself?
It's good to be here. My name is Frank Hunleth. I started the Nerves project and I work on it now with Justin Schneck and a team of others. So I am an embedded systems programmer, and what I'm looking to accomplish with Nerves is to bring the Erlang and Elixir ecosystems to embedded devices.
That's kind of a wild thing. We started talking about this one about 2.5 years ago, something like that.
I think so. Yeah.
Yeah, it seems like we were at the Lone Star Elixir back when Jim Freeze was running it. And one of the things that we talked about was that it was a little bit unusual to have this advanced functional language applied to embedded systems. So what does Elixir in general bring to embedded systems?
I think it's not only Elixir, but I think the important part is the Erlang virtual machine. I think that's where that started my initial interest in the whole bringing Erlang and the Beam languages into the embedded systems world, because there's this when you're programming the embedded systems that I had been, we've been taking a lot of third-party code. We've been bringing in a lot of software packages. Reliability was a very big problem for us. One of the nice things about the Beam is that there's a framework for making pieces of software reliable, and that was something that you could kind of do in C and C++, but was really hard. Then, as I've been working with Erlang and then with Elixir, there are quite a few other things that are pretty cool that I get to use. And the functional programming language, certainly aspects of it certainly have been super useful in making very repeatable, reliable, understandable code, working with other packages. Much simpler than to me than taking one of the big C++ libraries. I've come to enjoy this, but I gotta say the OTP, that's what got me hooked, and it's been going from there.
Yeah, I remember when we were actually building with a bunch of mentees, right? And these people had no sense of how hard some of the hard problems were, right? I mean, you look at some of the things in the home now that aren't built with nerves, and you think, how do they do that, right? How do they get this reliability? But what was funny was when we built this photo booth with the mentees, there were places when we had like a systemic crash, right? And it
Yeah.
just we had them all over the place because these were tough problems that we were trying to solve. And it was sometimes hard to tell that things weren't working as we coded them because the device would just kind of wake back up and
Well,
keep working.
well, that's kind of like the aha moment that all of a sudden you're. Oh, so I guess if I go back to when I was working with, um, well, part of my career I was working with TV set-top boxes, and the one thing that was endemic in this set-top box field was putting feature after feature after feature into these boxes, because they always had to do everything. It was a consumer market, and that's how they were promoted. And you just start adding stuff, and inevitably one piece of the system would end up causing some side effect on the other side. And you just trying to figure out how the whole system worked or kind of debug this thing was very hard. And I think that's like one of the features of Erlang, is that kind of like, libraries and modules can be isolated, they can restart, and sometimes, the system just recovers on its own. And that's just like the best thing in the world, because it's no longer like a big fire drill to try to figure out how to fix it. It's can be, the immediacy has worn off, and you can kind of fix it at your leisure, or maybe in a little bit more leisure. Yeah, I love that part of it.
So one of the things that's cool is as I teach, I talk about like a ninja move, right? Is like with OTP, it's the idea of reduce.
Yes.
And with nerves, I think that there's this silent thing that a lot of people in the nerves community have been getting really good at, and that's using nerves to kind of capture what's happening within the community, right? So people talk about when they see the garden bot, which is kind of this little mini automatic robot gardener that'll kind of detect things that are that are green that are supposed to be growing, and let them grow, or not supposed to be growing, and it'll kind of chop them out, or it'll detect and provide the exact amount of water, or pH, or things like that. But I've noticed more and more that some of the best and coolest Nerves applications are about how do you collect data and how do you know what's happening in the world.
People use nerves all over the place. It's kind of random where it comes from. And use cases that I never imagined. One of the first ones was on these tugboats and towboats, just to coordinate all the sensor data coming from all the different kinds of devices that you put on the boat to bring it to the captain in kind of a sane way. There's been quite a few farming related things. Like, it's not just the farm bot, it's also people doing industrial style farming, indoor farming, and using it to automate different aspects of their operation. And then there's like data center stuff that just comes up where it happens to be very convenient to have like a little device monitor some aspect of how the data center is working, whether it be power or kind of some sort of temperature control aspects to be able to, I guess, look at how that those systems are running and feed that back to whoever's maintaining the data center. And as opposed to like the kinds of systems that I actually work on, which are more home automation or properties. So for us, it's part a device that enables some IoT features in homes, but it's also used to monitor various aspects of a property, so that, for example, if like a water heater goes bad or something, that's detected and reported back quickly, and the different people are notified to fix it, or to even just watching temperature in vacant apartments, which, to avoid wasting a lot of electricity in those cases.
Or letting pipes freeze and things like that, right?
Yeah, sure. Yeah. There's just a lot of maintenance like things that are kind of boring and in the background, but in the big scheme of things, they can cause some pretty big bills if you don't catch problems in time.
So what are some of the sensors that you're excited about interacting with in the nerve space?
I think it depends on what I'm working on, right? It's I think the ones that I'm interested in working with you are more the air quality, the environmental types of sensors, mostly because those are the feedback is very direct and important to, like, us, right? We breathe it, we have to live in nice places. We want to live with and breathe nice air. When it comes down to it, there's always something interesting about each of them. Like, it's hard to play it's hard to pick favorites or anything, because it's like even some mundane stuff really has some interesting attributes on it when you get down to having to make it work in a device. I hope that we get into some of that with the environmental sensors too. There's a lot of complexity and a lot of science and engineering that's gone into some pretty tests that seem pretty simple, but yet when you work at the hardware level at these, to get this raw data and distill it into something that's human actionable is pretty interesting.
I think about all the different sensors that you use in home, right? Is this door open? Even like a garage door, which is kind of is this on a particular plane, or is this thing in motion, or is somebody home, right?
Oh yeah, and going through all the like failure conditions for this, like nothing. Sometimes when you get into building these things in products, like nothing is really easy, right? They're like when you start putting these things in the real world, and you remind me of a really fun sensor I've worked on, which was I was working on a medical device. The purpose of the medical device was to do a lot of diagnostics on your retina, right? So there are a couple diseases that we're particularly interested in, but everything was kind of similar in that we flash light into someone's eye. We have an electrode that measures the retina's response to that light, and we also have a camera that measures the pupil size so that we can produce the right light. And we get this instrument out, right? We train it on as many eyes that we can get, and then as soon as we get this out to the wider market, and all of a sudden people start using it on pets. Like one big field was veterinary, and all of a sudden I'm I'm in charge of the computer vision side, and all of a sudden I get these eyes in, and I'm like, this eye just doesn't look right at all. And then my boss is just like, yeah, that's from a dolphin. Like, what is it doing? Like, why are you giving me dolphin eyes or like a goat eye? Like, sometimes he just troll me with goat eyes or cat eyes or something ridiculous. And then I find out that, yes, there was like a legit use for the device in these veterinary markets. So you just never know.
So what else should our Groxio users know as they attack their first couple of Nerves projects?
Number one, there's like a lot to learn for everyone. So I really encourage people not to get discouraged. It's like there's a lot of pieces, right? And the pieces can be tackled one at a time, right? It's not like you go full Nerves and you're going super embedded on some low cost device and having firmware updates and doing the whole shebang. You don't have to do it all at once. Doing these things one at a time as you get used to the hardware is super helpful. I think the thing that takes some time is getting kind of used to the debug. Just getting some practice at the feedback loop to be able to say, oh yeah, I tried this thing on the hardware, it didn't work. Let me see if I can just modify something quick, and getting kind of used to that, trying it out. Because when you're interoperating with the world and with these sensors, sometimes the specs aren't clear. The real world is a messy place. So it's just the I think the route that I take down is if you're coming new to this, maybe try out just a sensor on some easy use platform, maybe one of the Nerves based images, maybe Raspbian if you like the Raspberry Pi. Start with that. Once you get kind of a feel for that, then go to the next step, and so on. And at some point, it seems like Nerves kind of fade. The part that's Nerves is kind of fade away. And it's kind of like, oh, I just built an Elixir project, and then I just used the Nerves infrastructure just to build this little firmware image that I put on my Raspberry Pi or BeagleBone or whatever. And it's kind of like, did you use Nerves? No, I didn't really use Nerves. It's just there. So it's kind of funny. There's the transition that occurs once the magic goes away.
Thank you so much for your time, Frank.
Thank you.